Dear students, so now in this session we are going to discuss properties of parallelograms. In our previous session, we discussed about the quadrilaterals. Then we discussed about different type of quadrilaterals like trapezium and parallelograms and kite. In parallelograms, we have defined, we also divided it into a rectangle, a rhombus, square, uh, and then we discussed in the last, which is not a parallelogram, that is a kite. Now we are going to discuss different properties of a parallelogram. That the first one is that a diagonal of a parallelogram divides it into two congruent triangles. The first property, what I can say, is that a diagonal of a parallelogram, okay, divides it into two congruent triangles. So let me write it down, and after that I will explain it in details. So let me write it down, dear students, here. A diagonal of a parallelogram divides it into two congruent triangles. Okay, so let me explain you further what is meant by that. A diagonal of a parallelogram divides it into two congruent triangles. So let me first give you a visual representation. So let us consider a parallelogram, something like this. What I'm going to show it to you. So if you see that ABCD is a parallelogram, correct? And in this parallelogram, there is a diagonal. It is AC. As you see the diagonal, that AC is the diagonal. Now, according to the statement, what you see here, this statement says that this diagonal AC divides that parallelogram into two congruent triangles. One thing too, we are able to see that it is in the two triangles. That one is ABC and another one is at ADC. These are the two triangles. This is one triangle and this is another triangle. But the point is that these two triangles are congruent, and we are going to prove it. How we are going to prove it? Let's see. Now, if you look into the in the triangle ABC and the triangle CDA, correct? So in the triangle ABC and CDA, so what I can write is that, let me use a different color. Yeah. In the triangle ABC and CDA, what you can say, dear students, is that BC is parallel to, AD. What you can say is that BC is parallel to AD, correct or not? And AC is a transversal, and AC is a transversal. So BC is parallel to AD and AC is a transversal. So then we can say that angle BCA is equal to angle DAC. Why? Because pair of alternate angles. So what we can say from here, that angle BCA is equal to angle DAC. BCA is equal to DAC. pair of alternate angles. Correct? Now, again, if you see that AB is parallel to DC and AC is the transversal, okay, so what we can say is that also AB is parallel to DC, AB is parallel to DC, and AC is a transversal. So then what we can say from here, from this information, we can say that angle BAC is equal to angle DCA. We can say that angle BAC is equal to angle DCA, so pair of alternate angles. Correct, dear students? All of you are able to get it? Any doubt? And one thing we can say is that, any doubt, dear students?
No, sir.
No, sir.
Okay, great. So first point what we get is that angle BCA is equal to angle DAC. Okay, so if I write it here, angle BCA is this angle is equal to angle DAC is this angle, and the other one is that if I do it in the red color is that angle BAC is this angle is equal to angle DCA is this angle. And the other one, so we found what? The pair of opposite angles are equal. Sorry, pair of angles, corresponding angles are equal, not opposite angles. Pair of angles are equal. And what we see is that AC is equal to CA. AC is equal to CA. There is a very important thing here. Why I didn't write AC is equal to AC? Why I wrote AC is equal to CA? That's the important thing. When I write AC in the left hand side, that is corresponding to the triangle ABC. And when I write CA, that is corresponding to the triangle CDA. Okay. So AC is equal to CA. So then what we see is that we can really apply that ASA rule, angle side angle. So and there are two angles, and what are the two angles? And the angles are if you look into this, that this is one angle, this is one angle, and they are included side. And in the red color, as I said, showed you earlier, this angle and this angle, and they are corresponding sides. Correct? So what you can say is that from understood this point. So there are two angles, and they are opposite, and the side, two angles and a side included between them, they are equal. So then what we can say is that from here, from this information, and from this information, what we can conclude is that we can conclude that triangle ABC, is congruent to the triangle CDA. That is actually by means of ASA rule. Correct, dear students? Anyone has any smallest clarification, smallest doubt, please feel free to me. Absolutely clear? So, absolutely clear, dear students? Any doubt?
No,
No,
sir.
sir. No, sir.
Okay. So now, the next property what we are going to discuss is that in a parallelogram, opposite sides are equal. Okay. The next one, what we want to say is that in a parallelogram, opposite sides are equal, and that I'm going to show it to you. Okay. Let me write it down first. Okay, dear students. So, what's the statement next? Theorem. What I wrote is that in a parallelogram, that opposite sides are equal. Okay. So, from the previous one, what we understood is that the diagonals divides the parallelogram into two congruent triangles. Correct. Correct. As we just proved it, the diagonals, divides that, triangle and divides the parallelogram into two congruent triangles. So, if I draw a diagram for that, what we get is that from the previous, theorem is something like this. So, from this, from the previous theorem, what we were able to prove is that the triangle ABC is congruent to the triangle that CDA. That sequence is very important. I explained in my earlier class on triangle that sequence is very important. Now, as they are, sorry, as these two triangles are, congruent, then what you can conclude from here? What you can conclude is that. So let me use a different color. So from here, what you can conclude is that AB is equal to CD. Obviously, AB is equal to. It is just a minute. Yeah, AB is equal to CD because that is the corresponding sides of the two triangles. So this is AB and this is CD. And also we can say the other two pairs, that is AD should be equal to BC. That AD, should be equal to, actually we can write is that CB. AD, the moment I write is that AD, it should be equal to CB. So AD is equal to CB. So we are able to prove that, the statement what I wrote, that in a parallelogram, opposite sides are equal. Okay. So dear students, the next theorem, what I'm going to tell you is that is something like this. In each pair of, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. So let us understand this thing. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Let me write it down, the statement first, followed by I will prove it. If each pair of opposite sides, if each pair of opposite sides of a quadrilateral or quadrilateral is equal, then it is a parallelogram. Okay, so let's see how we can prove it. Okay, dear students. To prove this, better to just a minute. Let me use a different color.
Sir, this is the inverse of the previous statement, right?
Correct. Exactly. If each pair of opposite sides of a quadrilateral is equal, then it's a parallelogram. You're absolutely correct, you are. But it is a converse of the previous statement, but we need to prove it. So how to prove it, dear students? So let's have this diagram here. Okay. Now, if you look into this diagram, that AB and CD are the of the quadrilateral be equal. Let us assume this thing, because that is what is the statement says. It is a quadrilateral. ABCD is a quadrilateral, and opposite sides. What are the two opposite sides we are concluding here, dear students? Sorry, it is that AB, AD, and BC. Okay, suppose AD and BC, we are assuming they are equal. So let me use a different color. So we say that AD is equal to BC. Correct, dear students? Now, absolutely, there is no doubt that these two triangles, one is that ABC and another one is the CDA, they are congruent. I hope there should not be any confusion here that why these two triangles are congruent, as we already discussed in the previous two theorems. So ABC is congruent to CDA. Now, as these two triangles are congruent to each other, then what we can say? Angle BAC is equal to angle DCA. This implies angle BAC is equal to angle DCA, correct? And angle BCA and angle BCA is equal to angle DAC, correct? So obviously from these two statements we can say that ABCD is a parallelogram, correct or not? Clear or not clear? Okay. And in fact, is it clear, right? Okay. In fact, what you can do after this class, you can make some kind of experiment. You can construct a parallelogram and measure its angle. What you will see? You will see that each pair of opposite angles is equal. Okay. You can try with many more parallelograms. Okay. It is a matter of an experiment of 10 minutes. Okay. You can easily construct a parallelogram using the geometry box. Just with straight lines, you can, and a graph paper, you can do it. And you can measure, once the parallelogram is constructed, then you can measure their opposite angles and you'll find they are actually, equal. So dear students, so with this, I would like to conclude the class here. In the next class, we will discuss the more theorems related to parallelograms. Whatever we have discussed so far, dear students, is everything very crystal clear, or you have any smallest doubt? Let me know.
No, sir, no doubt.
Okay.
No, sir.
Everything got clear? Okay. Thank you
Yes.
very much. All right.
Uh,
Thank you.
so we have to